Now I will discuss the plasma arc welding, and in that welding process we have seen that the metal plates we have joined using the heating with a constricted arc between the electrode and the workpiece, means that is the workpiece, and that is the electrode, non-congeal tungsten, that is the non-congeal tungsten electrode. And between that two electrode, when we supply the power supply, due to that things the arc will be generated. Okay, that is the arc, created arc, that is the created arc. That created arc creates the heat to that particular weld faces. Okay, and due to creation of the arc to that weld faces and also melted to that weld faces, and due to melting between two plates, what happens? Due to melting the metals of that parent metal, that will be converted into molten state, and it will be then after that it will be converted to solidify bonding to the both the particular plate. Means here we have seen that that is the non-congeal electrode. That is the non-congeal electrode. Okay. Then that is the shielding gas nozzle. That is the shielding gas nozzle. Okay. And through that spaces we provide the shielding gases, and through these spaces we send the plasma gases. That plasma gases converted into ionized plasma column, and that is the pressure arc. And one end means negative end connected to that particular non-congeal tungsten electrode. Another end of the power supply we connected to the workpiece, and that workpiece will be connected to the earth. Okay, and due to generation of the heat by the using the plasma arc, it will, that part will be converted into molten state, and then it will be converted into welding joint. And here we considering the water cooling nozzle. Sometimes due to higher heat generation to the using arc, sometimes for controlling the temperature of that particular non-congeal electrode, sometimes we using the water cooled nozzle. Now plasma arc welding. In that welding process we are seeing that that is the direction of the travel. Okay, direction of the travel, and here also we use the coolant for cooling purpose, and shielded gas also, plasma gas and also shielded gas also used, and that is the tungsten electrode, and that is the filler rod. Sometimes also we have used the filler rod, and that is the base metal. Okay, and plasma stream. Here plasma gas means plasma streams we provided, and using that plasma gases the plasma arc will be generated. That arc helps to convert it into molten state, and then it will be joined. Then solidified gas, shielding gas means some shielding gas we have provided to that particular welding electrode, and orifice constricted arc, and that is the orifice means constricted arc. Through that arc, through that particular nozzle, the plasma gases we have supplied, and that is the solidified metal. What are the plasma? Plasma means heated extremely high temperature and ionized so that become electrically conductive. Means plasma gases we have sent through the electrode. Okay, that plasma gases heated extremely due to power supply, and due to providing power supply, that plasma gas is converted into ionized plasma column. Means that actually is a commonly considered as a plasma arc. For plasma arc welding process, this plasma to transfer electric arc, means that will be converted into transfer to electric arc to that particular workpieces, and that plasma arc helps melted by the intense heat of that arc and fused together. Means that generated plasma arc converted into heated metal part, means molten part, it will convert it, and then that arc fused together, means molten state will be converted to that particular weld faces, and then both the faces will be joined. What are the objective of that plasma arc welding? First, to increase the level of the arc plasma in controlled manner. Okay, then achieved by the gas nozzle around a tungsten electrode operating on a direct, means here we have used the direct current source. Okay, and providing a gas nozzle around the tungsten electrode, means one gas nozzle also we have used there, through which the plasma gas will be supplied for creating the plasma arc. What are the variants? One is transfer mode. In the transfer mode, we have seen that arc will be generated between the electrode and the workpiece, used for high speed welding. Okay. Another used that ceramic material, steel material, aluminum alloy, copper alloy, titanium alloy, nickel alloy. Another non-transfer mode, here we have seen that the struck arc will be generated between the electrode and the nozzle, not workpiece. There it will be connected electrode and workpiece, that will be connected to the electrode and nozzle. Thus elimination necessary to have the work as a part of the electrical system, means here workpiece is removed from the electrical system, and arc process produces plasma relatively low energy, means in that cases low energy density arc will be created, and that is the non-transfer plasma arc welding, not a part of the electrical circuit. Plasma torch may be moved from one workpiece to the other without extinguishing the arc, and in that way the intense the welding faces and create the welding. In that picture we have seen that the arc will be generated between the workpiece and the electrode, means one part will be connected to the negative end of the power supply, other part will be connected to the positive end of the power supply. Here that is the transfer mode. In case of non-transfer mode, the electrode will be connected to the negative end, and other part, means nozzle will be connected to the positive end, that is the nozzle that will be connected to the positive end, means here workpiece directly not connected to the power supply. What are the equipment? First, power supply, a DC power source using generator or rectifier having drooping characteristics, open circuit, near about voltage we have used 70 volts. Okay. Sometimes rectifiers preferred over DC generators. Rectifiers are generally preferred in case of DC generators. Another, here generally we have used the helium inert gas, open circuit voltage about 70 volts, are near about two power source, means this voltage can be obtained by the two power sources that are be initiated using argon as a shielding gas. Okay, normal open circuit. And high frequency generator we have used also in that arc ignition. What are the shielding gases? Generally, in case of shielding gases, we have used, means what is the purpose of the shielding gases? From the reaction, means from the prevent from the atmosphere, means it does not react with the oxygen, means it does not form the oxides. Two inert gases we have used. Generally, two inert gases or maybe one inert gases we have used. Generally, argon commonly used, helium, sometimes argon hydrogen, argon helium mixtures we have used in that welding process for shielding purpose. What are the welding parameters? Welding parameters means current near about 50 to 350 amperes. In case of voltage 27 to 31 volts. And gas flow rate, it will be varies from 2 to 40 liters per meter. And temperature of the jet, means temperature of that particular jet, means arc near about 28,000 degrees centigrade or 50,000 degree Fahrenheit. In case of force modes in plasma arc welding, microplasma welding, current varies from 0.1 to 15 ampere. Arc length is varied for up to 20 millimeter and used for welding of the thin sheets near about 0.1 millimeter thick and wire and mesh sections. In case of medium plasma arc welding, welding current varies from 15 to 100 ampere. In case of keyhole welding, here current near about above 100 degree means above 100 ampere. And also plasma arc penetrates the wall thickness, and that will be used for high quality joints in case of air-pressed chemical industries to weld thicker material up to 10 millimeter thickness stainless steel of a single pass. What are the advantages? In that cases we have seen that the permits faster, means here faster deposition rate and also faster welding rate. Another, uniform penetration is also possible in that welding process. Welding quality is also good and also excellent weld quality. Can produce radiography quality at high speed also. Can weld steel pieces up to halving thickness to quartz bar joint also possible using that welding process. Useful semi-automatic, automatic process also we can convert it in that welding process. Very fast and clean welding process. Require less operator skills, means that welding process are automatic welding process. By using the control system we control that welding process. And high penetrating capability means keyhole, very depth will be penetration depth also higher generated in that welding process. What are the disadvantages? Special protection is required from the infrared and ultraviolet radiation. Okay, needs high power electrical equipments also, and gives out ultraviolet infrared radiation generated in that welding process. So protection is necessary. Operator produced high noise on the order of 100 decibels. Means in that welding process very noise, higher noise will be produced. Expensive equipments, very costly. That plasma arc welding setup very costly. Can weld up to 20 millimeter thickness can be joined using that welding process. High distortion wide weld as a range of high heat input generated in that welding process. More chances of electrical hazards, means very high temperature and very higher power source is required. So maybe health hazards, maybe electrical hazards occurred in that welding process. What are the applications? Where we have applied? Aerospace, food stuff, chemical industry, machine, plant construction, automobile, ship construction, tank equipment, pipeline construction. In that cases, we have used that plasma arc welding process. What are the outcomes? From that lecture, students have learned about the explosive welding, forge welding and plasma arc welding. Later we will discuss about that welding process. Already I have completed that friction welding, friction stir welding and thermite welding already I have completed. Plasma arc welding, that is the non-conductible tungsten electrode, water cooled constricting nozzle, means for controlling the temperature, and shielding nozzle through which we provide the shielding gases and through which provide the plasma gases. That this is the DC power source, workpiece, plasma gases, shielding ends, and one end of the non-conductible connected to the negative end, and that will be connected to the positive end of the power supply. And when we switch on the power supply, the arc will be generated. That arc created the molten state to that particular welding faces and joined accordingly. And that type of welding faces will be generated.